Hi, everyone. I'm Lily Chiu from UT Austin. It's a great pleasure to introduce this year's SIGCOMM session on cellular networks. Cellular networks play a significant role in almost every aspect of our life, including work, social life, entertainment, and even emergency response. So cellular research has profound impact on us. Over the past few decades, we see a significant revolution in cellular phones. 1G phones were bulky and hard to carry. 2G cell phones became more portable and also introduced text messages. iPhone 3 was a great success and paved the way for the future smartphones. 4G allows us to enjoy mobile internet. Now we are in the era of 5G, which is still being deployed. Here's a table that summarizes different cellular network generations. As we can see, almost every 10 years, there's a new cellular generation, which increased the data rate by at least 10x. Their capability also improved significantly thanks to lots of innovation across the network stacks, especially the physical layer. 1G transmits voice calls using analog signal. It is inefficient and vulnerable to noise. 2G transmits digital data. It introduced text messages, multimedia messages, which became so popular that led to wide adoption of cell phone. 3G uses packet switching to enable mobile internet. Moreover, it enhanced the data modulation and coding to yield significant speed up in data rates. 4G introduced OFDMA and MIMO, which stands for multiple input and multiple output antennas. This led to orders of magnitude increase in the data rate and enable high quality video streaming and gaming. 5G further leverage massive MIMO and millimeter wave to potentially achieve multi-gigabits per second data rate and 10 milliseconds latency. 5G has lots of exciting innovations. Millimeter wave is one of them. It refers to frequency above 24 gigahertz. At this frequency, there's more bandwidth, so we can support high data rate. Moreover, millimeter wavelengths also suggest that we can achieve high tracking accuracy, which opens the door to new applications, such as motion tracking, environmental sensing, health monitoring, and sensing for communication. While millimeter wave has more bandwidth and can support high data rate, the range issue becomes more severe. Signals attenuate much faster over distance, and signals also gets harder to penetrate through objects. Therefore, MIMO and small cells are being used in millimeter waves. In addition to physical layer innovation, 5G also innovates in upper layer stacks. For example, network virtualization allocates resources to specific application and specific clients so that it can provide quality of service to individual users. The high data rate and low latency of 5G enable new exciting application. For example, it makes it possible to distribute computationally expensive machine learning tasks across devices, edge computers, and cloud. It also supports latency-sensitive IoT applications and embrace VR and AR. In this session, we have 4 exciting papers. The first paper studies virtualized radio access network, VRAN. The next 2 papers provides in-depth studies of 5G measurement for reliability, performance, and power consumption. The final paper explores cellular network architecture. Next, I will briefly introduce each of these papers. The first paper has a very ambitious goals. It uses cloud to simultaneously support 5G VRAN and other applications. RAN is responsible for communication between base stations and mobile phones. It used to be implemented in hardware. VRAN virtualized the hardware function using software. It is challenging to guarantee 5G stringent latency requirement on commodity devices. Providing latency guarantee while sharing VRAN with other applications is even more challenging. This paper proposed an interesting design for predicting VRAN job completion time and schedule jobs based on this prediction. This is the first paper that considers running VRAN with other applications in the cloud while providing latency guarantee. This is scientifically interesting as it pushes things to the extreme. Moreover, it provides a comprehensive evaluation study. The next paper performed a large measurement study of cellular reliability on 17 million Android phones, over 34 hardware models, 3 mobile ISPs, and 5.3 million base stations. These are huge numbers. Achieving such large-scale analysis is challenging on its own. Moreover, there was a lack of sufficient tracing and logging to enable analysis. As a result, they also developed a new monitoring tool. In addition to reporting problems and the analysis results, they also developed solutions for those problems. In particular, they also designed an algorithm to select radio access technology to decide when to switch between 5G, 4G, 3G, and etc. Moreover, they also designed a scheme to optimize 3-stage failure recovery. They release patches to the real user and show improvement on their phone. So this is an excellent example of timely and in-depth study. And the measurement also makes impact through code release and deployment for real users. The next paper looked at a complementary issue. They conduct a performance comparison between 5G versus LTE in terms of throughput, RTT, and power consumption, as well as quality of experience. The study was challenging because 5G coverage was sporadic. Moreover, in order to compare between 5G and LTE, they need to rule out other performance bottlenecks in the cellular networks. The paper reports a number of interesting findings, including power consumption between 5G and 4G. Based on these insights, he also developed a nice algorithm to optimize power and user experience. He also released data sets and tools. This is a timely study of 5G performance and power. The final paper studied a very interesting issue: how to lower the barrier of entry for new cellular operators. The problem is challenging because small providers have limited coverage. They are at disadvantage when competing with the larger providers. Ideally, we would like the users select the best cellular provider at each location and able to switch to different providers as they move. He also developed a new cellular architecture that uses a broker to interact between the user and cellular providers. Through the process, they decouple mobility management, authentication, and billing from the data plane. The topic is of great importance, but underexplored. The novel design of this cellular network architecture are likely to inspire lots of follow-up work. Thank you very much for listening. I would like to invite you all to attend their talks and provide feedback on the Slack channel.